Hi, good afternoon. Welcome to our webinar, Unlocking the Power of AI and Machine Learning with Databricks, Strategies, Tools, and Best Practices. My name is Maria Alvarez. I am the VP of Sales at Focal CXM. Before we get started, I wanted you to know that we will have time at the end for any questions or comments. So please post your questions in the QA link and we will address them at the end of the presentation. Today, we will explore the transformative potential of AI and LLM solutions on the Databricks platform, guiding you from end to end through the AI lifecycle. We're very happy to have Venkatha Joji Kothra with us today. Ms. Joji is the Director of Data and AI at Focal CXM and oversees the data and AI solutions in both the commercial and the public sector. Additionally, she serves as an adjunct faculty member of data analytics at the South New Hampshire University. Ms. Joji has extensive expertise in data modernization, architecture, governance, and enterprise modeling. She is a pioneer in next-gen tech solutions and well-versed in big data, cloud computing, distributed data processing, system upgrades, and business process transformation. Thank you for being with us today, Ms. Joji. I will pass this along to you now.
Thanks, Maria, for the introduction. Thank you, everyone, for joining today's webinar. I appreciate you all taking time for the webinar presentation on unlocking the power of AI and machine learning with Databricks. Here is a quick peek at the agenda and topics discussed in webinar today. First, we'll start with introduction and then move on to conducting machine learning on Databricks and how to perform Gen AI activities on Databricks, followed by a demo of all the topics discussed through slides, and then moving on to the Q&A session. Focal CXM is dedicated for enhancing employee and customer experiences through utilization of data, AI, and Salesforce. Focal CXM has achieved success in delivering diverse data and AI services to esteemed clients and stakeholders. In addition to that, Focal CXM and Databricks are trusted partners and play a crucial role in advancing lakehouse architectures, AI activities, enabling organizations to harness data effectively while maintaining trust and compliance. Moving on to the first topic of today's webinar is how to conduct machine learning and data science activities on Databricks. With Databricks, it's easy to implement the full machine learning lifecycle on a single platform with end-to-end governance throughout the machine learning pipeline. Single platform is the key over here. Conducting all the activities within a single platform, not moving from storage layer to other layer, is the ease of conducting machine learning and data science activities within Databricks. So here, as the flow on the diagram shows, first the data would be onboarded into a Unity catalog. So Unity catalog, we also have talked in our previous webinar on how it maintains the governance all throughout the platform. So data being onboarded on Unity catalog, it ingests with all the important lineage and the important information on the data itself. So that way it can be governed very well. It is secured, governed, trusted, and compliant. And from there, from the data itself, the feature stores would be built. What is the importance of feature store and why feature store is needed for machine learning activities? We are going to discuss in detail in my upcoming slide, but feature store is the key to maintain all the machine learning activities and remove redundancies and have operational efficiency on maintaining different machine learning algorithms within an organization. Any feature which has been built into the pipeline can be reused by maintaining the feature store, so that multiple data scientists who are building features can be reused within the models. So that way it can remove the redundancies and would be a cost-effective solution on running machine learning on Databricks. In addition to that, all the data within the Unity catalog and feature store would be fed into the model training, and the training on Databricks can be conducted in different fashions. First, running an AutoML experiment or running the notebooks. All the machine learning can be fed into the notebooks and run end-to-end machine learning workflow through the notebook, and MLflow experimentation. So we're going to talk about all this in detail in the upcoming slides. After the model is built, then next is model management. So when the models are built, there's huge teams of data scientists, huge team of ML engineers conducting different activities within the dev environment, production environment, UAT. How is all this going to be managed? So all this management is through model registry. That's another key important feature of Databricks, where any model which is built even as a trial version or even as a lab version, that can be also registered in model registry, and versioning can be maintained on the model. And the best version model would be deployed into a model serving as a real-time endpoint or as a batch inference. So depending upon the use case, the production mode of deployment of the model can be selected, whether it should be a batch or real-time inference. And all the activities are on through the platform is being monitored by a good monitoring system on Databricks by using Lakehouse monitoring. This is a very, very important tool. I cannot emphasize enough on how important the lakehouse monitoring is, because any data drift, so the data which has been trained for a model, and then suddenly there's a new column, there's a new structure, there's a new data type. We don't want the real-time endpoints to just fail with small things, but instead these needs to be troubleshooted at an early on phase. So all these would be detected by lakehouse monitoring. It gives lot of notification and flagging, alerting, saying that, oh, there's a data drift detected. There is a model drift detected. The training model accuracy is 90%, whereas the validation model accuracy is just 80%. See if the model is underfitted or overfitted. All these notifications are auto-generated within the Lakehouse monitoring system. So that's so efficient for having a good AI ML platform, and then gaining trust of the customers and stakeholders on the machine learning models being built on Databricks. So moving on to the next topic, which is ML runtime. Why is runtime so important? It's the runtime is nothing but the compute being selected for conducting machine learning activities. Here, all the machine learning activities within Databricks has a separate runtime than the standard operations like data ingestion or any other data pre-processing activities. Machine learning has a separate runtime within the compute. It supports, the reason of having this is that it supports all the built-in ML frameworks. So any framework which is being used for machine learning activities, that is pre-built within this machine learning runtime. So the data scientist or a ML engineer who is performing all these activities doesn't have to think about loading libraries, setting up the environment, and spending days together to set the environment itself. Instead, this built-in ML runtime would provide everything at a single click just by selecting the right compute. So that is the ease of introducing ML on Databricks. So there is no need to worry about setting up the environment, but instead Databricks does that for you. So it's a built-in ML frameworks with model explainability. I think most of the machine learning community would know how important Shapley is. Shapley tries to explain each and every feature on what feature needs to be consumed into the model. So model explainability is pre-built within the runtime itself. So either the model is within MLflow or AutoML, that can be easily understood on which feature is most important to improve the model accuracy. And then in addition to that, all the distributed training computes are pre-built within the ML framework, which means that there's a right version of Spark, there's right version of Joblip. So that way we don't have to upgrade versions, worry about any versioning of all the environment and libraries which needs to be set up for the machine learning platform. It's all like gone. There's no need for the data scientist or ML engineer to worry about. Just select the runtime and done. And in addition to that, the AutoML activities can be conducted with a simple and easy way. And in addition to that, HyperOpt, which is a hyperparameter tuning mechanism. How important the hyperparameters is for the model performance, bagging and boosting and improving the model accuracy. I cannot emphasize enough on having hyperparameters for performance of deep learning models and advanced machine learning models. In addition to that, it supports the hardware, which is NVIDIA and CUDA. These are the GPU and CPU clusters which are needed to conduct activities like LLMs or Gen AI and deep learning activities. With that, I would like to talk about the next topic, which is AutoML. What is AutoML? The name itself suggests that something is automated. So here, it simplifies the machine learning activities to the data sets. Any new data set which is coming to the data scientist or data science team, machine learning team, So even worrying about what the data set is, how to have a predictive power for this data set, or what features are there, how I have to even start. In all this, the simple solution is AutoML. It solves the main two key points, which is quickly verify the data set itself, understand the data set itself. Exploratory data analysis is a key, and most of the machine learning projects, 80% of the time is allocated for exploratory data analysis, because that is the most important thing to have the machine learning projects to be successful. And here Databricks has AutoML capability, where any new data set which a data scientist receives, just try to run it through AutoML. AutoML actually runs this data set and say this is the best performing model on this data set. And then from there, that can be a starting point for the data scientist. It gives a guide and direction for the data scientist on, okay, this is how the data is looking like. And then from there, they can take and enhance it to the next level. So what AutoML, like what are all the models which are available in AutoML? So AutoML supports, and the roadmap on AutoML is being enhanced, but in currently, as of today, these are the available models within AutoML. There's different classification models like decision trees, random forest, logistic regression, and regression models, all popular regression models, even the XGBoost, and from forecasting models like Prophet and AutoRima. All these activities can be conducted using AutoML. Then moving on to the next topic, which is MLflow. So what is MLflow? I know like there are several platforms can be used for conducting machine learning activities. It can be done in AWS using SageMaker. It can be done on Bedrock. It can be done on Azure ML. It can be done on Databricks ML and GCP using Collab. So what is speciality of Databricks? Speciality here is the key or ease of operations performing machine learning activities and GenAI activities. The ease of operations comes with MLflow. MLflow is the lifecycle management in Databricks. Whole lifecycle can be managed with ease. So MLflow is an open source platform for machine learning lifecycle. So operationalizing, productionalizing the models, all these are simple by using MLflow, which is an operations which are running behind the whole Databricks workspace. So it is divided into four components. The first one is MLflow tracking. Tracking records and every experiment conducted within the workspace and even across the workspaces of Databricks. So every experiment would be tracked, the code built, data, configs, everything is versioned. So that way it is easily tracked and maintained, and the right version can be productionized. And it provides a project mechanism for a machine learning, which is like more structured format for the ML operations itself. It packages the whole ML project into a single project, and then so that way that any machine learning model which has been built on a particular features or data set, reproducibility of the machine learning model can be done. So usually a model has been built, and then if the same results have to be reproduced, there's definitely a lot of challenge currently today. But MLflow takes care of it, and then it provides a trust and compliance that the model can be reproduced with the same results. And there's a lot of models which MLflow would support on the platform itself. And then model registry is a centralized collaborative lifecycle management. Every model which needs to be deployed as a batch inference or real-time endpoint or a serving endpoint, every model needs to be registered first into the model registry, unless until a data scientist or machine learning engineer cannot deploy the model. So that way it gives a high level of control on the operations, and then make sure that the operations are done efficiently. Next, coming on to the feature store. So what is feature store, and do we even need to invest in building a feature store? Can't we just consume the data set right away from S3, or right away from Azure Blob, or even from the Delta table directly? Can't we build a model? Yes, we could build a model, but here feature store brings more efficiency to the model accuracy. Feature store is nothing but a centralized repository that enables data scientists to find and share features. And it also ensures that the same code is used for the computing the features. I talked about reproducibility. How can we get reproducibility for the model is if a calculation or a metric is being built, then it needs to be reproducible. How it can be reproducible is logging it as a feature in feature store. So that way that feature would be maintained all the time using a batch or real-time data, and then that feature would be taken into model so that there's no change in any code or calculation. If a data scientist has built a feature, for example, a cumulative metric or an aggregated metric, a revenue, cumulative revenue, that can be logged as a feature. It can be used for multiple use cases, multiple models. So that feature can be used for that model, and resharing of the features can be done within the data science teams. So that's how feature store can be served as a centralized repository for all the machine learning features. In addition to that, it enables discovery, easy discovery of all the features. And feature store provides auditing and logging capabilities. So auditing and logging is so important because as the system grows, as the models grows, as the organization grows, there's n number of models, n number of features being developed. Redundancy and operational overhead is going to be decreased by maintaining a perfect solution like feature store and model registry. So that way, it is not growing in the bad way. And feature store helps handling scaling requirements, storage, retrieval, serving, everything can be managed efficiently, and it allows for reusing the features which I talked about. So this is an efficient way of maintaining the machine learning processes within the platform and within the workspace. So after selecting the model, after consuming features, how to deploy the model within Databricks itself? What are the challenges with this real-time machine learning systems? Of course, currently in today's market, there's a lot of challenges with building real-time machine learning system. Most of the ML models which are in lab and which are in experimentation doesn't go into production because that's how the research and development operates within machine learning. It tries to every data science team tries to experiment on different ways on getting predictive capabilities for data, and then try to uncover hidden patterns of data. So machine learning infrastructure is hard to maintain because real-time systems needs to be very fast and scalable. It is a rapidly changing environment. The model which is there today, a TensorFlow library which is there today, and some capability which is there today might not be there tomorrow, and they would have upgraded. Some models which are there in Hugging Face libraries, maybe there's upgraded version, and that requires some additional environment setup. So all this rapidly changing environment and Gen AI environment today, maintaining the ML infrastructure is very hard. We need a strong platform to maintain all this infrastructure in place. There comes Databricks, where it is easy to operate. And then deploying real-time models needs disparate tools. So there's lot of systems, lot of libraries. It can be done in multiple ways using different frameworks. So deploying all these models and maintenance of the models needs a strong platform. So, what are the different modes of model serving? Model serving can be done in a different fashion. This is universally across any cloud provider for that matter. Model can be deployed using different patterns, but in Databricks, the Delta Lake or feature store, which maintains the features or which provides the source data sets for the models itself, and then that source data sets would be consumed into our training notebooks or AutoML notebooks, and then from there, once the notebook is performing better, the best performing model would be registered in the model registry for deployment. So any activity which has been done on the left side, unless it has been registered in the model registry, it cannot move to the right side. So that is the control which is established within the platform. So that way, like any other models or previous version models or for models which are not performing well, they suddenly don't go into production. So model registry is the control which is acting in between the left and right situations over here. And the model can be deployed as a batch mode, streaming mode, real-time mode, or edge. So batch mode usually depends upon the client and stakeholder use cases. Which mode is good for deploying the model is chosen. For example, there's a customer score which is important for lead generations. So whether the customer would be a payer or whether the customer would be converted. So to understanding this, that scoring model is definitely important, but does it need to be real time? Maybe it can be done in a batch. Maybe it can be done in a latency of 1 hour or 4 hours, so that we know that when customer a high dolphin or a high performing customer is logged into the application, then immediately there's some personalization can be done for that customer, saying, hey, you are a valuable customer, come to the platform. So creating that kind of personalization definitely is needed, but does the model need to serve real time? Maybe batch mode is better for that. So that way, like, it provides a capability that a model can be deployed as a batch mode, or it can be deployed as a streaming mode. So most of the use cases needs real time scoring, real time metric calculations, and some of the financial models needs real time calculation of the metrics. For all this, streaming mode of a model is very, very important, where the data just comes in through the event hubs or through the messaging hubs, and right time they would be consumed into the model endpoint, into the model inferencing endpoint, and then it needs to predict right away. So that streaming use cases can be supported using streaming platform. And in the real time, like usually the model would be deployed as a REST API, or it will be deployed to a containers. So real time model endpoints serve many use cases, like either product recommendation, customer scoring, or funnels, hiring funnels, different use cases for that matter. The machine learning models needs to be deployed as a real time model. And Databricks also supports Edge. It's same like how Edge on AWS, Neo Edge on AWS. Sometimes a model needs a special case deployments. For example, a model needs to run on a submarine, a machine learning model which serves a self-driving cars, or a TensorFlow model, deep learning model which needs to be deployed on a autonomous devices. So for all this, the model needs to be deployed at the edge. So for that, edge deployment is also supported with Databricks. So moving on to the next topic, which is Gen AI capabilities on Databricks. How does Databricks support this Gen AI lifecycle? Generative AI, of course, definitely currently today market is all about Gen AI and 100% focused on which platform can support all the activities which I need to perform. So Databricks here provides a unified platform, unified Gen AI lifecycle. So it just maintains circular cyclical operations over here. Unity Catalog mainly maintains the governance and access control of the whole models itself, and MLflow maintains the tracking of the models. Feature engineering and serving would help making sure the models are consuming features, and Mosaic AI model serving helps deploying the LLMs. And Mosaic AI vector search maintains that the vector search databases can be a queryable databases, so that way we can understand what is the relevancy and similarity of the vectors and indexes being created. And Lakehouse monitoring monitors the whole operations within the LLM lifecycle. And AI Playground is one of the addition capability on Databricks, where we can test the different Gen AI foundational APIs. And then Mosaic AI model training is again another capability within Databricks, where Mosaic AI provides fine tuning of foundational LLMs on Databricks. So DBRX, this is a state-of-art model of Databricks. This is a native state-of-art model of Databricks where the LLM has been built, which can serve different wide variety of use cases. And then it follows the all other features which I have said, that LLM lifecycle would be managed on Databricks using DBRX. In addition to DBRX, all the foundational models are available on Databricks itself. But the speciality of DBRX is nothing but it uses mixed of experts architecture. MOE architecture, just like Mistral LLM, here mixed of expert architecture makes sure that there's different agents deployed, and whenever there's a need for retrieval, augmentation, or generation, or context generation and documentation, it just deploys multiple agents, and then multiple agents are going to fetch the responses and context immediately. So MOE architecture is a successful LLM architecture, and it mimics or it takes the good features of Mistral AI, and then in addition to that, there's a lot of capabilities added to DBRX, so that it can outperform most of the LLMs which are available in the market today. As I showcased here in the slide itself, DBRX surpasses GPT 3.5 and Gemini in benchmarks on math, language, and different operations. And also, it is fine grained and maintains MOE architecture so that efficiency on this LLM model can be increased. And model inference is faster than other models like LLM, Llama 2, and all. So I know, like, I did a lot of talking, but I want to switch over real quick to the demo on all these components and then come back to the slides. So moving on to the demo of these different components, hope you all can see my screen and the different components which I talked about on Databricks. So this is the Databricks workspace. And starting with the compute, I talked about specific needs for running machine learning activities, the computes. So the runtime here needs to be selected based on what activities needs to be performed. So machine learning compute itself, like, we have to select the compute based on the necessity, whether it needs a GPU based compute or whether it needs just a CPU. So depending upon the need, the compute can be created and it can be actually used for the model development. In addition to that, let me move on to the catalog explorer. So what is Unity Catalog? How does it even manage everything? So Unity Catalog is the centralized schema and repository to maintain all different data sets over here. In addition to data sets, the models, volumes, and tables, everything can be managed within the catalog itself. So for the demo purposes, different data sets and tables have been built, and then all these are in the single platform where the model can consume it right away from the data tables. Other than that, Unity Catalog has an immediate integration with the external data. External data is like a S3 bucket, which has been built in a bucket which has been built in S3, can directly managed as an external data location. So the artifacts, model artifacts, can easily read and write through the external data or external managed location. So if we want to onboard a new data set or ingest by a partner, that can be easily done by clicking on adding data, so that data set can be added to the Unity catalog itself. So add data would enable the users to add, if the data needs to be streamed through Kinesis platform, if the data needs to be loaded from S3, if the data needs to be loaded from any other platform systems here, depending upon mode of ingestion, whether it needs to be a file format, images, any computer vision models, all those needs to be uploaded as a file systems. So that can be uploaded to the volumes. Any structured data can be uploaded directly to the catalog. So it supports both kind of data formats. And other than that, Unity Catalog also has a capability of delta sharing. So if in an organization a model has been built, which is definitely serving very well, then that model can be shared through Databricks marketplace right away, and then monetize it. The model can be monetized. Any data set also can be monetized, and then immediately make it available for the customers out there. And the organization can be a data provider and have monetization on the models itself. So that's how the Unity catalog works. Let me move on to how actually to run the AutoML experiment. So moving on to this machine learning capabilities over here, I would like to first start with the experimentation. So here, this is the area where AutoML experiment can be created, or a traditional end-to-end machine learning and deep learning models can be run using traditional experiment, and then Mosaic AI model training can be done using this experiment tab. So for the interest of time, I have conducted few experiments as for the demo purposes, and then I would go through how this looks. So I have conducted a fraud prediction model on a open source data set, and then the model actually, once I have integrated my data set right away into the model, then it actually starts evaluation and starts building the model. So as everyone can see here, it started with the accuracy and random forest regression model, and the accuracy is 0.9. And the AutoML keeps running the training experiment till it settles down at a good score. So the evaluation RT score is 1, which is the best case scenario over here. And then it provides a notebook for the best model, and it provides a notebook for the data exploration it has conducted. In addition to that, it also gives like several warnings to the data scientist on understanding the data set itself. It says that customer ID unique values are in string columns. So what AutoML has done on that. And in addition to that, it shows what are the high correlated columns found. So it gives several warnings to the user saying that this is how it looks. And other than that, like it also creates the model notebook, the data exploration notebook automatically created by the AutoML experiment, where it creates this notebook, and then from there, like the data scientist can easily understand using pandas profiling, like how it has done data exploration, what are the variables, how is the correlation, are there nulls, are there missing, and then all the exploratory data analysis is just conducted in a single click, and then AutoML provides all this information to the user. And in addition to that, it provides the best notebook, best model notebook, and right away builds a starter notebook. From here, any hyperparameterization or any advanced concepts needs to be handled. This is a baseline standard start a notebook for the data scientist where they can conduct, and then it provides the code, and it also showcases each and every artifact which it has created for the model experimentation. And then the notebook would actually help the data scientist to understand how the experiment has been conducted, and then see the evaluation of the model itself. So this is how the AutoML can be used to actually run the experimentation. And from there, depending upon the use case and scenarios, this can be used or it can be enhanced to the next level. So the notebook itself showcases the clear structure of what the pipeline has done, how it has done the whole operations around background operations of the model itself, and then how the random forest regressor has actually predicted. So all those, every important little detail has been showcased in AutoML experimentation notebook. And Sharp, which is again the model explainability. Sharp is also integrated within AutoML. So which feature is best to use in the model can also be known using Sharp. So this is how the AutoML experiments can be conducted. And then just moving on to the next topic, how to conduct a MLflow experiment. So MLflow experiment, this is a starter notebook for that matter, like starting from regression, classification, basics, traditional machine learning to advanced deep learning concepts, artificial neural networks, RNN, recurrent neural networks, advanced deep learning, and even reinforcement learning can be supported within the notebook itself end to end, starting from the data setup, Unity catalog setup, till the last deployment of the model to model registry can be done within the same notebook. So that is the ease of the operations which Databricks provides. So here, as we are moving along the notebook, it set up the catalog, it reads the data. From there, it visualizes, conducts exploratory data analysis, and then from understanding the data set itself, pre-processing of the data, and from there it trains the model into a baseline model, and tries to get the validation done on the baseline model. From there, it here feature importance is also the key, just like how Sharp does the feature importance on AutoML. Here feature importance is derived using code. So understand which features are more important for the model itself, and then the right model can be actually registered within the model registry using MLflow. So the MLflow package right away provides all the operations where with single liner code, the model can be registered to model registry, and from there, the model can be actually deployed as a batch inference. So here the MLflow actually is loading the model. It conducts the experiment on the model, and then from there, the model can be actually deployed using a batch inference here. So this is how the model can be deployed as a batch inference. So I just pulled over the delta table, where the model is communicating back and forth. So here the model is also within the platform itself, and the data set is also within the platform. So that's the ease and beauty of conducting the operations on Databricks. So the data set is right over here, and then from there, the model is also right over here. So this is the model which is conducted, and then the data set is reading and writing back to the Delta table, which is governed by Unity Catalog. So that is the ease of having everything within the single platform. So the next notebook I would like to bring upon is vector search. So conducting vector search within the operations within the notebook operations itself. So here, this example actually, it's an open source example from Databricks where how to build a vector search using Python SDK. So I have run this notebook on conducting a vector search, taking a source table which is from the basic Wikipedia, and from there, like I have built a Delta table using all the Wikipedia text and embeddings, and from there, the embedding model which has been used to create this vector search endpoint is the popular BG large embedding model. Again, the accuracy on the model and success of the model of BG is very high. So this model has been used to create an index, and from there, the index has been generated. And then the index right away shows up. Once the index has been created, this is the data set which has been logged directly into the Delta table itself, and the index has been created within the Delta table Unity catalog itself, and right away the endpoint can be queried. So here I can ask like some of the questions which are in the which are fine tuned within the data set itself, and then that provides me the results. So I'm directly querying the endpoint, and this endpoint can be served into any application or any model, so that way the index endpoint can be integrated for any LLM capabilities. So that's about how to conduct experiments and build indexes. Next topic I would like to talk about is playground. So how playground can be used. Here, playground is nothing but testing different models. Databricks provides a space where we can test different models here and choose which model to actually implement for the use cases itself. So here we can ask any simple question, and then the model actually gives the performance of each. So I'm just entering a question, a simple question. And then we can test like what is the response rates of each model. I'm comparing Meta Llama 3 over here, DBRX, which is Databricks model, and Mistral. So it shows like all the prompts, all the models have taken the same prompt, and then showcases what is the fast return and the information the model has retrieved. So the DBRX has taken zero point 0.4 seconds to retrieve the first token, whereas MetaLlama is 0.64 seconds for the first token, and then it has 471 tokens generated, and Databricks DBRX has 108 tokens, and Mistral has 269 tokens. So Playground can be enhanced to the next level. We can use, we can change the features, change the structure, and change the tokens also. So that's how Playground can be used for exploring different large language models. And at the end, I have showcased here how to perform RAG operations on the models itself. So conducting RAG on Databricks is automatically following the same mechanisms on data preparation, cleaning the data set, creating chunks, and then running it through the embedding model, and from there deploying as an endpoint. So let's see one of the endpoint which has been created using Databricks documentation, and query this endpoint. So here, this is an endpoint which has been created using RAG, and RAG has been performed on different documents which have been processed. And then, querying the endpoint over here. So that returns the response right away. So this RAG can be definitely served as an endpoint and integrated to the applications, front end applications itself. So the rows indexed are 5,000 rows have been indexed, and then it has consumed all the different documentations which have been processed using Databricks documentation. And these are the content of each document, and then the lineage, the ID and URLs of the documentation. And then in addition to that, the same mechanism actually builds an evaluation set on the documents also, where it tries to tag and then evaluate what is the performance of the model based on each request and response, whether the request has fetched the real response. So that way, like, the model is not hallucinating. So that way, in the background, the model also like checks all the time that LLM is performing well, and then it is trying to actually fetch the right response and no hallucinations. So that's how RAG can be performed on Databricks itself. In addition to that, the Databricks has many foundational models which are available as direct serving endpoints. Right away, this serving endpoint can be deployed for prompt engineering, or it can be used for fine tuning the model. And then from there, this model can be fine tuned or implement RAG on the model, and then it can be deployed. So, and every model endpoint can definitely be queried and then try to understand the response times and the nature of how the model is performing. So, different foundation models which are available on Databricks. Here is a list of the Meta Llama 3 and then DBRX, Mistral, and other foundational areas. Other than this, any third-party Hugging Face models also can be right away integrated using Hugging Face connectors. Databricks has easy integration to Hugging Face connectors and OpenAI for using GPT models. It has connectors to every possible third-party APIs, so right away they can be consumed within Databricks. The one last topic I would like to cover today very quick and then end the webinar. Here, Databricks Marketplace. This is one other important capability of Databricks, where once a model has been prepared and then the model has been done, the model can be actually we could provide that model as a provider, and that model can be actually deployed for other community or other Databricks community over here and start monetizing on the model. So for example, here there are many models which are available in the marketplace which can have right instant access. So this is one of the model which is in the marketplace where instant access can be provided. And the notebook of the starter notebook of the model is also available in the marketplace, which can be right away imported within the environment. And then some of the models itself, like probably those models are for getting access. So this way the model can be monetized. So these are some of the biomarkers and popular models are built by intelligent IMO organization, and these models are actually they have published in the marketplace. So those models can be right away consumed within our environment by getting access. So marketplace is another important area where a successful model or data set or tables, everything can be shared across the different communities, so that way everyone can utilize this. So this is a quick demo of the all the components of Databricks itself. With this, I would like to move over for any question and answer session.
Thank you, Jyoti. We really appreciate taking the time to share your in-depth knowledge with us. Let's see if we can get to some of the questions. Okay, I have one here for you. What are the best practices to run deep learning or machine learning models on Databricks?
Yeah. Definitely, the best practices, as I have mentioned, the first thing is to use MLflow, because MLflow monitors the whole model from the background. So that way, like any model, machine learning runtime and MLflow and registering the model within the model registry, all these are very important components. And then in addition to that, to run the deep learning, the main important thing is like it needs a GPU clusters, and selecting the right machine learning runtime like 15.3 or the latest available version. This this information can also be found on the Databricks release notes on what runtime has which Scikit or TensorFlow Keras libraries, so that way the deep learning activities can be performed. So all this would set up a good environment to run deep learning experiments.
Okay, thank you. Second question, what are the outstanding factors of DBRIX compared to other popular LLM models?
Yeah, as I mentioned, like DBRX is definitely as, the metrics outside within the market definitely says that DBRX has outperformed some of the open source models over here, and then the model has a mixed of experts architecture. That's the important feature of DBRX. So where like it has a lot of efficiency in augmenting, indexing, vector searches, embedding. So each and everything, every activity of LLM which needs to perform in the background for text generation, all this is conducted as a MOE architecture, and then it has like 36 billion parameters and additional tokens, and even the cost efficiency is the key over here. It is cost effective, and the provisioning throughput of DBRX is less compared to Llama 3 and Mistral. So that way DBRX can be coming at 2 times lesser cost compared to other LLM models.
Okay, I have one more that just came in. How Databricks is different from Azure ML, and what are the main differences?
Azure ML, kind of Azure ML and Databricks ML mimic each other, because Azure ML right away integrates within Databricks, and Databricks has like a Azure Databricks component to it. There's open source Databricks and Azure Databricks. So if the ecosystem is in Azure, then directly Azure Databricks can be launched, which has AutoML, MLflow, MLlib, and as well as Azure ML right away integrated within itself. So they are like friends, I can say, like they are hand in hand if Azure Databricks platform has been onboarded. So this environment which I'm showcasing here is AWS Databricks. So it provides the capabilities very similar to Azure ML, but again this is not the Azure component of it. So that's the reason like it has MLflow and AutoML. But if the environment is integrated to Azure ecosystem, then that Databricks would be Azure Databricks, which has Azure ML automatically on it.
Okay, thank you. And one more, can Databricks handle external third-party LLM models?
Definitely. In addition to these are all the foundational models within Databricks. And in addition to that, if there needs to be an external model, definitely through marketplace, all the third-party models can be right away ingested within Databricks. So here, for sample, I have ingested some of the marketplace models which are third-party models, and then that shows up in the shared models, because I'm sharing the model from third-party sources. In addition to that, any Hugging Face models, I have to ingest them. Then right away, the Hugging Face implementation can be easily integrated within. It's a single line API call to Hugging Face, and then right away, those models can be used in Databricks environment.
Okay. Jyoti, thank you again. This was very comprehensive. I appreciate your time and joining us here today. Everyone, thanks so much for coming. You'll be able to find the recording of this webinar at www.focalcxm.com. And if there is any questions or you need to reach somebody, please feel free to go into our website and we'll connect with you guys later on. Okay? Thanks again for your attendance. Appreciate it and have a great day.
Thank you all.